So, we've been working with these right triangles. And we're going to continue working on them for a couple more days. This is one of the few sections that are, they're word problems. Plain and simple, they're word problems looking at elevation and depression. So, elevation. Elevation is if you're looking straight out. That would be kind of like ground level, sea level, stuff like that. And then you look up for something, that's elevation. So if you're looking up to see something, that's elevation. Then depression is if you're looking down to see something. That's depression. So elevation is looking up, depression is looking down. Brian's kite is flying above a field at the end of a 65-meter string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So, Brian's flying a kite at the end of a 65-meter string. So, I've got Brian here, little stick figure Brian, and he's flying a kite, and the string is 65 meters. So, I've got my kite up here. There's my kite. The angle of elevation, so we have this. The angle of elevation of this string is 70 degrees. So I have 70 degrees here. And I make a right triangle. And it says, how high is the kite above Brian's head? So this is what I'm looking for, is I'm looking for kind of the vertical height of the kite. So that's X. Draw the picture. The key to any word problem is usually to visualize it. That way you know what you're looking at. Just to read a word problem and try to just figure out what's going on is nearly impossible without a picture. So you kind of pull everything apart and you make a picture of everything you're hearing. Once you have a picture, it's just like we did last week. Exactly what we did last week. Because now I've got a picture to go from. So same as last week, I'm going to mark on my sides. So which one's the hypotenuse? The 65. My angle's here, so that means X must be the opposite. So now we pick a trig function. So which trig function am I going to end up having to use? Sine. So my problem is going to be sine of the degree, which was 70, equals opposite over hypotenuse, X over 65. That's my sum. So the tricky part of any word problem is just to visualize what's going on. Once you get a picture down, you just work through it. So I want to solve for X, so what's my next step?
Put the X, and then do division.
I don't want to do division.
So multiply 65 by 70.
Right. Since this is X divided by 65, to get rid of a divided by 65, I'm going to multiply by 65. So that's what goes in the calculator. Same as last week. We had problems like this on that graded worksheet. So 65 times sine 70 equals 61, basically 61. So 61 meters equals X. So 61 meters. So therefore, the height of this kite from the ground, technically from the line from his hand, but it's pretty close, is 61 meters. This would be 61 meters. So number one, does number one make sense? Does everybody see how I drew the picture? That's the most important part, is drawing that picture. Is everybody okay there? Number 2. From an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground is 28 degrees. Find the distance from the plane to the building. So it says it has an airplane of an altitude of 1,200 meters. So it's 1,200 straight up and down to the plane. So I've got my plane here. Yeah, I can't draw. Doesn't look like a plane, I know. But I got a plane up there. Now here's the tricky one. So I've got my plane flying. My plane is going to look down at a building at a 28-degree measure. So the plane is going to look down at a building at a 28-degree measure. So there's my triangle. But the 28 isn't really part of the triangle. The 28 is kind of outside, which means I still got to figure out what's inside. That's the tricky part about this particular problem. So if the 28 is this angle, what can I do to find the angle actually inside the triangle? Well, this whole corner is going to be how many degrees? 90. So if the corner is 90, I can take 90, subtract 28, and I get 62. So therefore, my angle inside the triangle is 62. So that's what makes that one a little bit tricky. Then it says find the distance from the plane to the building. So from the plane to the building, because the building was down here, is 62, or that's the x, sorry. That's what I'm trying to find. Find the distance. So now I have my problem set up. Well, the hypotenuse, that's what I don't know this time. Longest side. 62. This must be the opposite, but there's nothing there. So this is adjacent. So this time I have stuff on adjacent and a hypotenuse. So which trig function am I going to have to use this time? Cosine. So I have cosine of the degree equals adjacent hypotenuse, 1,200 over x. Well, this is the other one. The first one I had the x on top, the number on bottom. So I divided by, it was dividing by the number, so I had to multiply to get rid of it. This time, it's the other side. So what did we end up doing last week to solve for x on this one? Right.
So the x equals 1,200 over cosine 62.
I have 1,200 divided by x. So the x I can send this way. So the x ends up on this side. And then that would be times cosine 62. So then to get rid of times cosine 62, the cosine 62 can come back this way. Or just remember to swap those out. So that's what goes in the calculator. And we had something like that on the worksheet, right? So 1,200 divided by cosine 62. And I get 2,556. 2,556 meters. So that's the distance to the building. 2,556. That's that distance. So number 2, does it make sense? Are we okay? Let's look at number 3. Number 3 is really straightforward. About as straightforward as they can get. From a point on the ground, 12 foot from the base of a flagpole. So from the point on the ground to a flagpole is 12 foot. So we're standing here. We have an angle of elevation. So if I look up 53 degrees, I can see the top of the flagpole. And I want to know how tall is the flagpole. So that's X. So that one's about as straightforward as they can get. Not a whole lot of surprises there. Now I want to figure out the trig function again. Well, here's my 90. So this time the hypotenuse, there's nothing there. So I can't use hypotenuse. I have my angle. So this must be opposite, this must be adjacent. So which trig function am I going to be able to use? Because I have stuff on an O and an A and an O. What trig function is that? Tan. So tangent of 53 degrees equals OA, X over 12. There's my setup. Well, same as problem number 1, I had an X on top and number on bottom. So to get rid of divided by 12, I'm just going to multiply by 12. So 12 times tan 53 equals X. 12 times tan 53, and I get 15.9 feet. So this flagpole is a 15.9 foot flagpole. 15.9. So almost 16 foot. You can round it to 16. That's the flagpole. So that's the thing with these right triangles, is right triangles are really helpful to measure things that you can't necessarily measure in real life. Like a flagpole, you might not be able to measure. A building, you might not be able to measure. A lake, you might not be able to measure. But if you create right triangles with things that you can measure, then you can find distances between things. Surveyors use this all the time to try to find measurements. Surveyors line things up, they figure out how many degrees things are, and then they figure out distances between things, how far apart things are. That's what surveyors do all the time. So number 3, are we okay? Number 4. Number 4, a plane is flying due east at 265 meters above sea level. The angle of depression of two ships sailing due east measures 35 and 25. How far apart are the ships? So we're in our plane. Our plane is flying. The plane looks down at a 35-degree angle and sees a ship out there, sees a boat. The plane also looks down at a little less of an angle and sees another ship out there. And I want to figure out how far apart those ships are. So basically, I've got 2 problems here. I've got one problem using the 35 and another problem using the 25. Both of them use 265. So my height, the plane is 265 degrees up. Well, this one's a lot like number 1, because I'm going to figure out this triangle. But the 35 is actually outside the triangle, because the plane's looking down at a boat that's going to be sitting out here at a ship. So this is 35. How many degrees is going to be actually inside the triangle?
90. Oh.
Together they add up to 90. So inside is going to be 55. And it wants to know how far apart the ships are, which would be basically sea level. I want to know this distance. So that's going to be an X. So that's the first problem. I'm just dealing with the 35 right now. Well, here's my 90. This is H. Opposite, adjacent. Hello, Mr. Rick. 8th period? Okay. Let me pause this. Resume. So, which trig function am I going to use on this thing? Tan. So tan oh, I'm still frozen. 1 sec. So tan of the degree, because I know the degree. All the ones today, I know the degree. Tomorrow we'll have some that I don't know the degree. OA, x over 265. That's my set. We'll just multiply by 265. So 265 times tan 55 equals x.
78.5 something, so 79.
79. 265 times tan 55. 378.
That's what I got.
378. Did you divide?
Oh, no, I just accidentally put 55 in where 265 should be.
Yeah. So it was 265 times tan 55. 378. You can put 0.5. If you don't put 0.5, that's fine. So that's the first shift. The first shift from here to here is 378, 379 meters away. Then I got to do it all again. So I'm going to do it again, but this time I'm still using 265, but this time I'm at a 25-degree depression, which means this angle in here is now 65. I'm still finding this. Well, before we type things in, do you think we're going to get a number bigger or smaller than the first one? Bigger. Because I'm not having to look down quite so far, so it's going to be further away. Setup didn't change. Tan 65 this time. Opposite over adjacent, x over 265. So 265 times tan 65 is going to give me my unknown. So 265 times tan 65. 568.3. If you just put 568, that's fine. And I'm at meters. This was meters. Well, I'm still not quite done. I've got one more step to go. Because the question actually want to know how far apart are the ships. So what's going to be my last step? Subtract these two numbers. So 568.3 subtract 378.5. I got 189.8. If you rounded, you probably would have gotten 190 meters. That's my final answer of how far apart the ships are. So that one really had two problems kind of embedded in one. Because I had to figure out the first ship, the distance there at the sea. Second ship, the distance, and I want to figure out how far apart they were. Are we okay there? Question? One more that I'm doing with you, and then you'll have the opportunity to work on some more. Number 5. A man flies a kite and lets out a 100-foot string. The angle of elevation to the string is 52. That should say degrees. I didn't get my O popped up to degrees, but that should say degrees. How high off the ground is the kite? How far away is the man from the spot directly underneath the kite? This is almost the same as the first problem, but the difference is there's really two questions. So again, I've got a kite string that's 100 feet. The elevation of this kite string is 52 degrees. So this is 52. The first question says, how high off the ground is the kite? So that's going to be the first thing I need to find. Then it says, how far away is the man from the spot directly underneath the kite? Oh, let's do this one first. X, then Y. Well, it doesn't matter which one's which. If I keep in the order here, how high off the ground is the kite? How far away is the man from the kite? It'd be that one. Like I said, whichever one you pick doesn't matter. So it's kind of the same thing as we did yesterday, or the first problem. So if I'm solving for this one, this is opposite, this is hypotenuse. So sine of 52, x over 100. Times sine 52, I get 78.8. So that means this is 78.8 feet. Then to do this one, this is adjacent. So this time I'm not going to use sine. This time I'm going to have to use what? Cosine. Because I'm finding the other side. So cosine of 52, x over 100. 100 times cosine 52 equals 61.662 feet. So that's this one. Now, before you get started on the back, quick question. So these two measurements, I mean, they're close, but they're not exactly the same. This one was 78, this one was 61. What angle would I had to have picked if I did want these two the same? May I have any thoughts? What angle would have made both these the same? Because I got a 52-degree angle here. This ended up bigger than this. So it'd have to be smaller. So what angle do you think would have ended up making them the same number? Do you have any thoughts? We go back to our special right triangles. If I have 45-degree angles, the two legs make the same measurement. So this would have been a 45, then this and this would have been the same number. So, the back. It's the same problems. All I did was change numbers. It's the exact same problems. All I did was change numbers. So what I want you to do is work on the back. Give the back a shot. Go ahead and stop this.